Yeah, so am I good to go? You see the presentation, okay?
Ja, jag ska bara introducera några små saker. Som sagt, jättebra. Tack så mycket att det funkar. Så att säga. Bara en introduktion. När ni ställer frågor och sånt så kan ni göra det i chatten. Jag vill bara uppmärksamma er på att chatten kommer att bli synlig i videon. Så vill ni att ert namn och era frågor ska synas i videon så är det helt okej. Annars så kan ni... Vissa gör en privat chatt med mig om de har en fråga. Eller så kan man ställa frågorna efteråt eller direkt till Allan i den här ni såg på första sidan så hade Allan sin e-mailadress. Ni kan ställa den där. Så
settings and audio device.
Vad gör du, Allan? Du är klar, så det är bara att köra.
Du är där.
Allan, hör du oss? Allan, hör du oss? Vi hör i alla fall dig. Jaha, vad händer nu då?
Try go back to this one and see what it says. So you could disconnect if you say press the one and then say mute.
Okej, jag får fortsätta hålla lite låda då. Igen. Att via Peters maskin att vi strax får in Allan. Det jag tänkte på var att förklara lite vad som händer i framtiden här. Det är en jättespännande, tycker jag, serie som jag måste säga som jag har varit med och skapat då. Så att jag har valt ut de människor som jag tror är bäst på de här ämnena. Och eftersom Azure är så väldigt stort så har jag ju valt att ha faktiskt 10 sessioner i den här serien. Så de 2 första sessionerna kan man säga har varit lite mer generella och lite mer övergripande med först introduktionen till själva Azure men också just hur man jobbar med virtuella maskiner. Dock är ju väldigt mycket i Azure tjänster av olika slag. Och det är nu vi ska börja prata om tjänster. Jaha, hör vi oss? Hallå? Hallå?
Yeah, Doug, I can hear you. I'm back now.
Bra, du har full frihet att starta nu då, som sagt. Och vi spelar in nu, så varsågod Allan. Och du kan ju börja med att presentera dig själv.
Yeah, great. Thanks very much. So my name's Alan Smith. I work as a consultant for Active Solution. And what I'm going to talk about today is the Windows Azure Service Bus. So I'm afraid it's just going to be slides and me sharing my experience. I did have a number of demos which I was going to show, but unfortunately I'm on a different PC at the moment. So I'll just run through these the slides. If you do have any questions, please feel free to send them to Doug Koenig, and he can relay them to me. And I'm happy to answer any questions or queries that anybody's got with anything relating to the Azure Service Bus technologies. So Azure Service Bus is one of the technologies in Azure that I've been very passionate with. I've started looking at this technology around 2007 when it was first released as something called BizTalk Services, and it's great to see the technology really gaining traction in the Azure community. And as you can see on the slide, Halo is actually using the Azure Service Bus Halo 4, and I've been spending a lot of time talking to Clemens Vasters and also seeing presentations by Hoop Samoa there. And this is, if you look at Channel 9, this is a really good webcast that actually talks about how they're using it in a really sort of high-scale production environment. I think they're handling something like 150,000 messages per second that they're running through from the actual Halo services. So that's a really large implementation of that technology. So talking about, why Microsoft has developed the Microsoft Azure Service Bus and what kinds of challenges it solves. This is a kind of scenario that you may be familiar with if you've got a line of business system or some kind of application within your data center or within your organization. and you want to make services available on the internet. And there's quite a big procedure that we've got to go through here to get this set up. We've got to start talking to the IT personnel. We've got to start looking at configuring the network to create something called a demilitarized zone. Even if you have a demilitarized zone created, you'll be needing to create a service host within that demilitarized zone, and then start configuring firewalls and creating external endpoints and things like that. You may even need to start purchasing static IP addresses, configuring those, and also working with domain names and getting all of that set up. Also, if you're interested in security, which most companies are, you're going to have to, registering certificates and configuring certificates and making sure all of those certificates are updated. And it's a lot of work that you have to go through just to, get a service enabled on the internet, and do it in a secure fashion that follows best practices. Another challenge that's very evident today is the amount of devices that people are using to connect to the internet. And not only the fact that we've all got many devices that we're using to access the internet with, we're accessing them from different places. We're going on 4G networks, we're going on networks when we go in coffee shops. I go to quite a lot of conferences, and any time anybody gets to a hotel or a restaurant or a cafe or a conference venue, the first thing that we're doing is connecting our devices up to the actual Wi-Fi networks, being able to actually get a connection to the internet. And so there's so many different ways that people are accessing the internet and accessing these services now. Cloud computing is also bringing a number of challenges. We're having many companies who are starting to take their first ventures into deploying applications to the cloud. So they're starting to build what we're terming as hybrid applications, where they're keeping most of their services on-premise, but what they're also doing is deploying, some of their services to the cloud. So they'll maybe have a time reporting system or a website or some of their actual back-end services that they're starting to move to the cloud. So we need to think about integration channels. How do we connect these cloud-based applications to the on-premise applications, and how do we ensure that we've got secure and reliable communications there? Things is another thing that's presenting challenges, and this is really an emerging technology. A couple of weeks ago there was a news report that said, according to Gartner, the Internet of Things was number one on the actual hype curve, meaning a lot of people are talking about the Internet of Things, a lot of people are starting to focus on and read about this technology, but it's not really sort of gained traction. It's not really become a mainstream technology. But I think that's going to change. I think that, in 4 or 5 years' time, when you buy a car, when you buy domestic appliances, when you get a coffee machine installed at your office, these devices are going to be connected to the internet, and they're going to be sending telemetry data, exchanging messages with back-end services. And being able to actually create and manage those back-end services is something that's going to be challenging for organizations. And at the moment, when we've got the emergence of these technologies, we've got the Internet of Things technologies emerging, we've got the number of Wi-Fi networks emerging, and the use of internet in telephone networks emerging, and also the emergence of cloud computing and cloud technologies. And this is really generating a critical mass for being able to generate these Internet of Things based applications. And I'll be talking about that in a scenario later in the presentation. So there are several patterns that have emerged for being able to manage these types of scenarios. The first pattern is the enterprise service bus. This really it was something that started to become popular around 2003, 2004, when Microsoft released BizTalk Server 2004. There's a guy called David Chappell who published a book called The Enterprise Service Bus, which was really a book describing the Sonic software technology, which was a company that David Chappell worked for. And ESB, or Enterprise Service Bus, became a kind of technology that lots of organizations wanted to buy into or create within their environments. I kind of find it a bit of a confusing technology, in that there's a number of vendors and a number of companies that are actually producing what they call an enterprise service bus. And their actual definition of an enterprise service bus is really the actual product that they're producing. So BizTalk has an ESB toolkit, which is described as an ESB, and various other vendors have their own enterprise service bus. One of the jokes is that ESB really stands for Enterprise Silver Bullet. It's something that the architects would like to have within an organization. But the challenge is that there's so many different ways of being able to define this technology. It's really hard to find an actual optimum solution. But I've taken the definition there directly from Wikipedia, talking about these components that can be used to manage application and services within an organization. So it provides services like monitoring, resolution, deployment and versioning within the actual functionality of that service bus. And it's a way of enabling services to be made available within an organization. Message bus is another term, and I find that a message bus is very, very similar to an enterprise service bus. And really, one of the main differences here, if I go back to the previous slide, with an ESB, the services that we're dealing with tend to be synchronous services. We're doing things like get customer info. We're making a request. We're getting back a response from that service. And we tend to think of these as being SOAP-based, request-response services. They can also be REST-based. But it's really a synchronous request-response service. Message buses, on the other hand, tends to be asynchronous. We're creating messages, we're publishing messages, we've got various other applications subscribing to messages. And these messages can be events, they can be documents, it can be something like, a customer places an order. How many systems are going to subscribe to that order message and to process those messages? But the key thing here is that we're doing things asynchronously. We're sending messages and we're receiving messages and processing those messages. So around about 2007, you may remember Microsoft was announcing a wave of technologies called Oslo. Nobody's really talking about the sort of Oslo initiative anymore that Microsoft came up with back then in 2007. However, quite a few of the technologies that we talked about when we were talking about Oslo are actually running in production. So the Microsoft Azure Service Bus was one of those services, and it really started out as Microsoft coming out with this concept of the Internet Service Bus, which was in 2007. And I was actually at this conference in Redmond, the SOA BP conference, when somebody called Donald Ferguson was announcing this technology. Now, we were really confused as developers because Microsoft was announcing this service bus that they were creating, that they had in preview mode. And the idea was that Microsoft were going to be hosting this technology for us. And everybody in the audience, the question that everybody was asking was, I want to buy this. I want to install this on premise at my location. I want to, run this and manage it and maintain it myself. And Microsoft was saying, well, that's not what we're going to do with this technology. We're going to host it, we're going to look after it, we're going to manage it, and you're going to pay a usage bill for being able to use that service. So it's going to be a software as a service type application. So the reason this confused everybody, this was a year before Microsoft actually announced the Windows Azure technologies, or came out with the actual concept of cloud computing and a cloud computing platform. But the actual the service bus, the thing that I like about it was actually the first piece of the Microsoft Azure platform, and it was available for use about a year before the Azure technologies came out. So if you look at the evolution of the service bus, as it's one of the earliest Azure technologies, it's gone through quite a few life cycles, as you can see in this slide. The stuff that I like is the stuff down at the bottom. So, we started off with a very basic relay service that was available in TCP. We then got message buffers. Message buffers were really replaced by the brokered messaging capabilities that I'm going to talk about a bit later on. And then we got the emergence of the enterprise application integration and the EDI technologies, which evolved into BizTalk services. And now you can see in 2004, we're using the SMBP protocol, service bus message message bus protocol, which is an open source protocol. We've seen so many improvements in the service bus, and it's really sort of emerging, in my opinion, to be an enterprise class messaging technology in the cloud. The thing that I'm not too keen about, you can see on the top, is that there's been so many different name changes in this technology. I think it's got the record in Azure of having the most different names. It was BizTalk services, then .NET services, and then we had this Fabric technology, and then Windows Azure, and then it was rebranded to Microsoft Azure. So you may hear people talking about the App Fabric Service Bus, or giving different names. I inadvertently call it the Windows Azure Service Bus because I'm so used to doing that. But the official name now is the Microsoft Azure Service Bus. So those branding changes have really gone in line with the technology changes. And this is continuous improvement. We're going to see more improvements in the service bus technologies going forwards, and it's really exciting to see those new developments. So a bit about the architecture of this. How is the service bus put together? There's not that much public information about how the architecture of the service bus is running. But it's basically running and hosted in Azure data centers around the world. So they build these sort of large deployments consisting of many servers, which is known as a scalability unit. When they start to reach capacity on that, they can deploy another sort of copy of that, which is known as a second scalability unit. And that will be able to handle a large number of users and a large number of messages, with customers like the Halo game, demonstrating that. The authentication and authorization was previously in earlier versions using the Microsoft Azure Access Control Service. The Access Control Service is now being deprecated, so we are seeing a change now in the way that the authentication is handled in the service bus. This is evolving, and will be evolving to use the Microsoft Azure Active Directory services in the future. On the back end, at the persistence level, they're using SQL Azure to actually store the data and persist the data. So when we send a message asynchronously through the service bus, that message is going to be persisted in a SQL Azure database. And the service bus is providing the various functionality, the relayed messaging, the brokered messaging, and the actual BizTalk services, the integration services that we've got. So let's talk about those technologies. The first one that I'll look at is relayed messaging. Relayed messaging really solves that problem. I'm just going to whiz back in my slides to these connectivity challenges and look at this connectivity challenge for services. Now, when I showed this slide, I was talking about how much pain you get when you try to build this scenario, because you've got to deal with DMZs and firewalls and IP addresses and certificates and domain names and all this type of stuff. And certificates and domain names expire, so we have to think about renewing those. And instead of doing that, what we can do to do pretty much the same thing is make a service available using a relay service. So we have our service host, which is sitting on premise behind a firewall. And normally when we have a service host, the service host is passive. It will basically listen on an HTTP socket or a TCP socket for a request to come in. And when the client makes a request to that service, that will activate the service. However, when we're using a relay service, the service host is actually active. So when we start the service host communicates with the relay service in the Azure Service Bus. And it says, okay, I'm starting a service. I want you to create an endpoint for me so people can consume that service. And provided the authentication works, we are, of course, using usernames and passwords. This is a secure connection that we're using here. An endpoint will be created on that service. Now, the interesting thing here is that the endpoint for the service is in the cloud. The actual service itself is running on-premise. It's hosted on-premise. So we haven't really moved the service to the cloud. We've really extended the service to the cloud. So the great thing is here that we don't have to move our servers anywhere. If we're concerned about data privacy, we're concerned about not having stuff deployed in data centers outside the country. This is fine because we've got all our services running on-premise. However, the endpoint is in the cloud, available on a secure connection. And that means a client can make a call to that endpoint. The relay service will do what it says, what its name describes. It will actually relay the service request down to the service host. The service host will process that service request, and it will return the actual response out to the endpoint, which will be sent back to the client. And this basically saves us, all the trouble of creating a DMZ, registering a domain name, dealing with certificates and security. Everything's handled by the actual relay service. I actually, when I was at a meeting in Microsoft, meeting the team in Redmond, I met a guy called Bert Craven, who was the chief software architect for EasyJet, the budget airline. And he basically used exactly this same pattern. The challenge that EasyJet has was they had a lot of services. They wanted to make their services available from mobile devices that their staff were using in the airports. So EasyJet basically transitioned during the CTP period over to using the relay service in Azure. And it was a really successful project. The interesting thing was he was saying in the early days of Azure, the charges were going onto his credit card. And he was saying the actual billing for EasyJet using this implementation globally for their organization was about the same cost as his mobile phone bill on a monthly basis. So it's really inexpensive to use this type of technology for enabling a service.
Allan, eller du kanske ska, är du klar med Relay Service? Jag har lite frågor, eller vill du att jag ska ta dem nu, eller?
Yeah, absolutely. I can take questions as they're going. Sure.
Det är frågor från mig själv faktiskt. Vad behövs där på servicehosten för att få den här Relay Service att funka? Vad är det för teknologier vi stödjer där?
Yeah, okay, so the technologies, this is all built on top of Windows Communication Foundation. It's a shame I don't have the demos running because one of my demos was just to basically show a Windows Communication Foundation service that's running on premise. And I actually enable the service onto the Azure Service Bus just by changing the configuration file that we've got, the app.config file. So I mean, Windows WCF developers, we all love our config files because that's where everything goes. We download and install the SDK. That contains a set of Windows Communication Foundation bindings. So we just flip over from, say, using the basic HTTP binding to using the net TCP relay binding. And really it's just a configuration change. That was another thing that was saying about the EasyJet project. They didn't need to change hardly any of the code in their services. They just changed the binding configurations for their services and the client binding configuration changes, and that enables the services to be available on the service bus. So if you have got an investment in WCF services, you can transition them to the service bus really just by making configuration changes.
En annan fråga, har du möjlighet att bara nämna den här nya teknologin som heter BizTalk Hybrid Connections i relation till den här?
Yeah, but BizTalk does have some functionality to integrate with the service bus. So you can, expose BizTalk server endpoints and BizTalk server services on the Azure Service Bus. You also have in BizTalk an actual adapter to communicate with the brokered messaging services. Yeah, so it is possible to take a BizTalk server orchestration, publish it as a web service.
Det är inte riktigt det jag menar, Allan, utan jag menar den här möjligheten att i Azure Websites och Azure Mobile Services också connecta till databaser och sånt via TCP/IP in över brandväggen.
Yeah, I mean there are a lot of things that you can do with the network configuration in Azure. Really, I'm just focused on the developer technology, so I haven't really looked too much into all of the virtual
jag kommer att skicka med en länk så att ni kan läsa lite om det, för en ny spännande feature som på något sätt egentligen lite överlappar den här featuren. Tillbaka till dig, Anna.
Yeah, thank you. Yeah, so another scenario that we can use, there's many scenarios that we can use this in. One is the clouds to on-premise. So what we're doing is we've got a web application that we're hosting in Azure websites. What we're doing here is we've basically got a service host, but we want to keep, for data protection reasons, we want to keep all our databases and servers on-premise in our own server rooms, but we want the web applications to be hosted in Azure. So what we're doing here is using the relay service just to make those services available to a web application that's hosted in Azure, and that means that we don't have to open connections in the firewall or configure networks. We've got that connection running in directly just to those particular services that are exposed. Another scenario is inter-organization communication, where we've got a couple of organizations, they want to share their services. So what we're doing is making their services available in the Azure Service Bus. So people in different organizations, different server rooms can communicate with each other using the Service Bus. Device connectivity is another one. Because these services are available publicly on the internet, we can use devices to be able to communicate with those services. So if you're building an application for your staff to use on the road, using them on their tablet PCs or on their mobile devices, you can ensure that when they actually leave the company network, when they go to a hotel or when they're at an airport, they can still access the services that you're running on premise. Then we've got, the concept of using the Azure Relay Service as an enterprise service bus. You could actually use it as an ESB, where you have a policy where all of your services are exposed on the service bus and everybody is communicating with them through the service bus. One challenge here is latency. As you can imagine, if all of your service requests have to go to Amsterdam and back or to Dublin and back, even though they're within the same organisation, that's going to prove challenging. But you do have the option of a direct connections, so if it is possible, the services will actually form a direct connection. The clients can actually connect directly to the service. And when that happens, you'll see a latency drop from about 150 milliseconds per call to about 20 milliseconds per call or 10 milliseconds per call. So you can actually resolve that issue of latency if you do want to actually create an ESP using the service bus. So that's covered relay messaging. I'm going to talk about brokered messaging now, and we've had these types of brokered messaging technologies available on the Microsoft platform for a long period of time. I think MSMQ has been around forever. I can't remember a time when it wasn't present on the services. So we've always had these concepts of we can create a queue, we can send messages to the queue asynchronously, we can have applications that are receiving those messages and do durable asynchronous messaging. This is what the brokered messaging capabilities provide in Azure. We have a queue, we have applications that can send messages to the queue. Those messages are then stored durably on the queue and can be received and processed by receiving applications. And the difference here is that when we actually create our queues, we're creating them in Azure, creating them in the cloud, rather than creating them on an on-premise service. So we get the durability and we get the high availability there. So the queues that we've got, they basically support this first in, first out processing. It's a simple point-to-point channel where it's just like MSMQ. We send messages to the queue and other applications that will receive messages from the queue. We've also got publish-subscribe messaging, which is implemented using topics and subscriptions. So a topic is like the receiving end of a queue. A client's application can send messages to a topic, and the message is published onto that topic. A topic can have 0 or more subscriptions, and the subscriptions can either subscribe to all of the messages that are published to the topic, which is a default option, or we can specify filters on those subscriptions. I think the maximum limit, we can have 2,000 subscriptions in any one topic, and you can also chain them together. So, one subscription can send a message to another topic directly, and that can have another 2,000 subscriptions. So you can send, broadcast messages to millions of devices if you need to. So this, if you're a BizTalk developer, is a bit like the BizTalk server message box database, in that you can publish messages to the topic, and then you've got various subscriptions which are a bit like the send ports, which can subscribe to messages and deliver them out to the actual destinations. So when would we use the actual brokered messaging capabilities? One of the scenarios is load leveling. You've got an application that's generating, a varying degree in load. And you've got an application that wants to process, or it can only process a certain number of messages per second, say if it's only processing 10 messages a second. So the peaks in load will just basically result in messages building up on the queue. And as long as you're not sending more messages per hour or per day than the actual receiving application can process, the queue is able to actually level that load. So the receiving application can just process the number of messages as it sees fit. If you do get an increase in load, you can add additional receivers to this application and have load balancing. So this means that the actual load is being balanced across multiple receivers. And the way that the receivers receive messages make it very easy to add additional receivers in an active-active configuration. And literally this pattern can scale up to thousands of receivers receiving messages from these queues and subscriptions. So it's a very good way of being able to distribute load. Also high availability. If one of the receiving applications fails for a certain period of time, as long as we have an active receiver, that can process the messages. So plural decoupling is another scenario. If you're basically aggregating messages on the queue from an application, you may choose to actually run a server for only a short period of time to actually process those messages, and then actually undeploy that server. So if you think about, you know, a technology like Azure, where you're being billed per minute for running your servers, you could choose to actually run the server for, say, 15 minutes a day, rather than running the server 24/7. And that's going to give you, you know, 95, 99% cost saving in the actual cost of having that server present. As long as, you know, you're happy with processing the messages at the end of the day, or, you know, spin up the server to process the messages once an hour for about 5 minutes. It's going to give you really good cost savings and make for a more optimal deployment. So this idea of temporal decoupling, meaning that the messages can be processed at a later point in time, is also a useful scenario. Så,
yeah. Allan, kan jag få ställa lite frågor?
Ja.
Det finns ju 2 kösystem i Azure. Det finns det som heter Azure Storage Queue, som Magnus Mårtsson kommer att prata om lite mer i framtida session. Och så finns det Service Bus. Kan du bara jättekort förklara skillnaden mellan de 2?
Yeah, I mean, it's like that with a lot of Microsoft technologies. There's, you know, 2 or 3 things that do have, you know, similar functionality or overlapping functionality. The 2 queuing systems have the different strengths and different weaknesses. So the storage queuing uses HTTP protocol, so it's a lot more lightweight to be able to connect to and integrate with. It tends to be easier to work with the storage queues. The storage queues, they have a message size limit of 64 KB. The service bus has a message size limit of 256 KB. I think the main difference, though, is within the actual functionality. I tend to think of the service bus queues as being enterprise class messaging. So they provide functionality like dead lettering, message deferral, the publish subscribe, the topics and subscriptions. The way that the serialization mechanism works on the messages is more sophisticated as well. Price-wise, I think the service bus messaging is a little more expensive than the actual storage queue messaging. But I'd say, you know, if you want to do enterprise class messaging, if you need, you know, duplicate detection, dead lettering, all that type of stuff, you're going to be looking at the service bus. If you want, you know, a simple scenario that's simple to implement, that you're already working with Azure Storage, then the storage queues are going to be good to go for. I do have a slide that outlines the differences, and I think there is stuff on the web that outlines the differences between the 2. So is that an okay answer for the question?
Det är jättebra. Bara en kort fråga till. Du pratade om det här med att batcha meddelanden, att göra decouple och sen köra dem med jämna mellanrum. Hur många meddelanden kan man spara i en queue?
So when you create the queue is actually set by a specific size. The default size is going to be 1 gigabyte, but you can create the queues up to 5 gigabytes in size if you want to. And there's no cost difference in choosing the actual size of the queue. So I mean, depending on your message size, you know, 5 gigabytes of messages is going to be a lot of data. It's going to be pretty challenging to fill up that queue.
Okej, tack så mycket Allan. Nu kan jag fortsätta.
Yeah. So working with the actual message entities, the first thing that we're going to be doing is creating something called a service bus namespace. So you log on to the Azure portal, go to the service bus connection, you create a new service bus namespace, and you'll choose a data center to create it in. The service bus namespace has to be globally unique, and that will be basically used in the URI for all of the entities that you're creating. So once your namespace is created, you can create your queues and you can create your topics. And once you've created topics, you can actually add the subscriptions onto the topics. And there's a few ways of doing this. You can either use the portal to create the queues, topics and subscriptions. You can use Visual Studio to do it, the actual Azure snapping. There's various third-party tools to do it, and you can also use the actual you know, code, a code-based way of doing it. I typically use code when I'm creating these topics, queues and subscriptions. So it can be done with C# using the API. The messages themselves, I think we do have some BizTalk developers. There's been some BizTalk questions coming in. So if you are a BizTalk developer, you're probably fairly happy with this diagram. That you have a message, the message has a couple of different sections. In this talk, we talk about the message header being the message context. This contains information about the message and message properties. And then we've got the message body, which is basically a blob of data which contains the serialized message content. So it can be a data stream, it could be an image, it could be JSON, it could be text, it could be the sort of serialized WCF or data contract serialized object that we're actually sending onto the message. It doesn't matter, it's just a blob of binary data. Other message systems as well will basically use this technology where you've got a message header and a message body. Incidentally, the storage queue messages don't really have this concept of a header and a body. They will have their actual content, but there's very little information in the actual message header on the storage message queues. The message header itself contains quite a lot of properties. I've basically shown a few of them in the actual diagram. The bullet points basically show the other properties that we've got there. As well as, and this is a bit confusing for me, you've got the actual properties in the message header, which you think about when you think about the .NET properties, but you've also got this properties collection, which is a name value collection. So if you want to actually add your own custom properties or your own specific properties, you can go into that properties collection and start adding these name object properties to your actual message there. So here we can see we've got things like the message ID, which is going to be unique. We've got things like the session ID if you're working sessions. We've got a label. We've got sequence number. All of these different properties as well. And this is really, in my opinion, what differentiates the service bus messaging from the storage messaging. It's more sophisticated in these features. For example, we can enable duplicate detection based on the message ID. So if we get two messages coming in within the same message with the same message ID within 24 hours, it will just basically suppress any duplicates. We can send messages in sequences using the sequence number, and we can have receiving applications that correlate these messages together. So when Halo is using the service bus, when a number of people are playing in one of the Halo games, you may have, say, 4 or 6 people playing in a tournament in Halo. That tournament, that online game, will have a game ID. And the sequence number for those messages that is related to that game is set in all of those messages. And that means when the scoring system is receiving the messages, it can aggregate together all of the messages that are coming with the same sequence number, all of the messages from that particular game. And then it aggregates the statistics together and publishes them, so people using Halo waypoints can see the actual game scores. So yeah, it's stuff like this that makes why I like working with the service bus messaging. We've got these enterprise class features there. So ways of sending messages are point-to-point messaging. If we only had queues, we would be basically having a sending application that sends its messages to queues. And we're dealing with this currently in the project that we're working on. We've got this point-to-point system that we're going to migrate and replace with a pub subsystem. In this system, the application that's sending the messages has to decide which queue it's going to place these messages on, and it's making all of the routing decisions. So that means we've got more logic in the sending application. So if we were to replace that architecture with topics and subscriptions, we could move on to a publish-subscribe system. Now here, the sender is just basically sending a message to the topic. It could be, that a user has been updated, a product has been updated. And we're going to have several applications that are going to respond to those changes. So when a user address is changed or when a product details is changed, different applications will respond to that. So within the topic, these subscriptions can actually filter who is going to receive that message. So when a product application product is modified, it could be these two applications that receive the message. When user details are updated, it could be this application and this application that receives the message. But the thing we're doing here is we're putting the actual logic here in the actual topics and the subscriptions, rather than in the sending application itself. And that simplifies the logic of the applications that we're building, and also makes the application more maintainable. We can add another subscription and add another receiving application if we want additional systems to be able to process those messages. So this is a scenario where we may use this. We've got a web application that's generating orders. We've got an ERP system that's going to receive all of the actual orders in the application. But the different offices, like the US office, the Canada office, the different regional offices, are only going to be receiving the orders that are actually specified for their particular order. We have a number of ways of configuring those subscriptions based on the actual properties that we've got in the message header. So very similar to BizTalk, you're basically subscribing to the messages based on stuff in the message header or in the message context, rather than stuff in the message body. So you can say if the company is equal to US, or if the office is equal to US, then let's subscribe to the message. If the message type is equal to order, then let's subscribe to that particular message.
Allan?
Ja.
Hur är det med om den här klientapplikationen sänder väldigt mycket meddelanden? Vad händer då? Finns det någon begränsning hur många meddelanden som kan skickas? Och vad händer om det blir för många meddelanden? Kan det bli för många meddelanden per sekund, eller?
Yeah, absolutely. I mean, everything that we're building basically has, limits to it. With the service bus, we have what we call sort of hard limits, or restrictions or limitations. So, for example, the 256K, the actual message size limit, is a hard limit. We can't go above that. We also have, and this is true on many of the Azure services, we have things called scalability targets. And a scalability target is, what capacity that system should have. And for the service bus queues and topics, we have a scalability target of 2,000 message operations per second. So message operations is basically a 64 KB chunk of data. They're used in the billing, so you'll build, a certain number of, message operations per dollar. Also, they're used for the scalability targets. So if I was sending small messages to a queue, I should be able to send 2,000 per second. It may, drop slightly below that. Sometimes it may be higher than that, but that's really, what we should be aiming at as a maximum. So for a topic, if I was looking at this topic here and all of the subscriptions were subscribing to that message, and I was sending small messages, then each message I send will be counted as 3 message operations, because all 3 subscribers are subscribing to that message. So instead of 2,000, it will be about 667 messages a second I can actually send to that topic on normal conditions. So we can think about load balancing, about multiple topics and multiple topics if we want to increase that. So I've talked a bit about the features that I think make this enterprise class messaging. So we do have dead lettering, we do have message expiration, we do have the option to defer messages and duplicate detection as well, and correlation. We've also got some form of transactions, so we can have a transaction that will basically send multiple messages to a queue or multiple messages to a subscription and so on. So there was a demo that I was going to show, which was basically going to show some of the actual features, which is going to be looking at how we can actually use that. The scenario here was that we were going to have an RFID reader. The RFID reader was going to be reading the RFID tags on goods in a shop. So when somebody checks out of a shop, each item that they're checking out with has an RFID tag on it. And that's going to be detected by this RFID reader. And these messages are going to be put on a queue, and they're going to actually go out to a billing application. So the challenge here is that when we actually scan the messages, what's going to happen is you're going to get duplicate messages going onto the queue, because we're going to move the RFID reader over the basket and say this item here is going to be generating, say, 3 or 4 messages as we scan around and try to get all of the messages. So what we can do in the itself is something called duplicate detection, and that means that if 2 messages come onto the actual queue with the same message ID, then one of those messages are actually going to be suppressed, or one of those will be suppressed. So if we do get duplicate tag reads for any particular message, that's going to result in those messages being suppressed. So if there's 14 items in the basket, we should just get 14 messages on the queue, 1 for each item. Enabling this is very straightforward in the Azure Service Bus. We can just turn on the duplicate detection, and that will basically filter out any duplicate messages for us. Another challenge that we've got here is, if this is running in a busy store, we've got these items coming through, and we kind of want all of the items in one basket to be grouped together into one order for processing. So another thing that we can do is we can use sessions and we can use correlation for these messages. So when we're actually starting to read the order, we'll generate a unique session ID for that order. All of the messages that are going to be published from that particular order will have their actual session ID property set to the ID for that particular session. And then the receiving application, when it's receiving these, it can basically receive all of the actual items for that specific session. So that will ensure that all of the goods for each particular order get grouped together in the billing application, and we're generating one bill for each actual person going through the checkout. And if there's multiple people going through at the same time, we're able to actually aggregate all of those different groups of messages together. So again, there's very similar concepts in BizTalk. We talk about correlations and aggregation and convoys and correlation subscriptions, correlation types and correlation sets. It's very similar technology that we're doing in the service bus as well. So another thing that I'll talk about just to round off the presentation is the use of these technology with the Internet of Things. Again, we're seeing Clemens Vastas here in the screenshot. This is another Channel 9 video that Clemens has done. And what he's got is, I really recommend checking out this video on Channel 9. He's got an Audi and he's got a Raspberry Pi in his car. And what he's doing is he's connecting to the interface. I think all modern cars basically have an actual interface to the onboard computer that's controlling the engine. And what he's doing is he's taking out telemetry data from his car engine and storing it, and the Raspberry Pi is processing that data. So he's taking things like the speed of the car, the RPM of the engine, the temperature of the engine, and that's being basically fed into the Raspberry Pi. What the Raspberry Pi is doing is it's using the actual Wi-Fi network that Clemens has got in his car, the 3G or 4G network, to actually send the information onto the Azure service bus in the form of messages. So what he does is he's basically sampling the data every second, and every minute a message is sent out by the Raspberry Pi onto the Azure service bus into the cloud. He's then got a worker role running in Azure, which is dequeuing those messages and putting the data into table storage. And the data in table storage is basically allowing him to actually go in when he gets home and actually look at the trip that he took. He can see his speed, he can see his engine RPM, the engine temperature, and all that type of stuff. And it would also be possible to actually subscribe to those messages and look at what he's doing in real time. So if you imagine you're a company that's running a fleet of delivery vehicles or a fleet of taxis, you'd be able to see in real time where those vehicles are. You'd be able to see how fast they're driving. You'd also be able to see things like the engine temperature. So if one of the engines is getting too hot in a delivery vehicle, you could generate an alert. You could phone the driver and ask him to check his van in for servicing, because if he doesn't do that in 2 or 3 days time, it's going to cause damage to the engine. And that's a really useful scenario. When you think about, Raspberry Pi is 250 krona. For being able to actually enable a fleet of delivery vehicles using that technology, it's very inexpensive to do that, and you can provide a lot of value in those types of scenarios. One of the pet projects that I'm working on is something that I'm calling Red Dog Racing. So I'm a Formula One fan, and one of the Formula One teams is called Red Bull Racing. And Red Dog was the code name for the Azure technologies when they were actually being generated internally. And so what I've done is basically got this project where I've actually taken an open source racing game, which is the XNA Racer, which is built on the Microsoft XNA platform. And I've actually integrated the racing game with Microsoft Azure, with the Azure technologies. And I did this, it's a fun thing to show at conferences and use on courses and do in conference workshops, where people can actually, take the game and they can actually, build the code that integrates it with Azure. And this is basically what the architecture looks like. I'm using the service bus to retrieve the lap and telemetry data. I'm using worker roles to actually process the telemetry data and store the telemetry data in Azure storage. So I'm using table storage to store that data. I'm using blob storage to store the driver replays. So when you actually are playing the game, you can race against the driver replays from previous drivers and so on. Then I'm using an Azure website to actually show the telemetry data and show how this data is working. I'll see if I can just escape from PowerPoint here and just show the actual website itself. If I can bring up Internet Explorer. I'm on somebody else's PC here, so I'm a bit new to this, but I don't really want to show that. So this is the actual website for the game, Red Dog Racing. It's reddog.azurewebsites.net. And as you can see, there's quite a few of us who've been playing this game. You can see Martin Belayu, Andy Cross, I think Magnus Mortenson's there as well. We were doing some recordings for the Azure Conf, which is going to be out next week. Maybe Dag could mention a bit about that. And during my recording, we were setting lap times. And for a while, I've been trying to actually beat Martin, who's set the fastest time. So we can go into the actual lap times here. This data is coming from table storage, and it's showing the actual details of who's got the fastest at lap time, how much damage they've got. You can see that it's very responsive, bringing back that data. Table storage will scale to billions of entities, and it's often used for these online games to actually do what I'm doing, do the actual high score tables. So we can actually go into Martin's lap, and we can see the actual telemetry data from what Martin was doing during the driving game. Again, this data is coming from table storage. The site is hosted in Azure websites, and I'm using a web API service to actually return the data in JSON format to this actual JavaScript graphing API. So you can see the actual speed that he was driving, you can see the damage that we were getting on the car. Here we can actually see the driver input, the throttle, the brakes, the gears, and the steering, and so on. The thing that interests me about this is I built this solution completely separate from the solution that Clemens Vaster's built, the solution that he was using in his car. But we basically spoke with each other in a link meeting and talked about our different solutions, and I'm doing pretty much the same thing as he was doing. I'm basically sampling my messages. I'm sampling once 10 times a second and sending the message once a second. But I'm using the same concept of having a high sampling frequency, a lower message send frequency. But we're basically sending messages to the service bus. We're both using worker roles to actually process the messages, and we're both storing them in table storage. He was slightly different in that he was using Excel to connect directly to table storage to get the actual telemetry data back from his car. But it's interesting to see that we'd both sort of chosen the same architecture, the same scenario for that.
Eftersom vi pratar om Clemens Vastes, kan du säga bara något jättekort om den nya tjänsten Event Hub som är väl lite liknande det här? Bara kort, har du...
Yeah, I mean, we've got a couple of challenges coming. I can probably whiz up to my slides, and
vi har bara några minuter kvar, så att ta det för lång tid.
Yeah, no, I want to save a bit of time for questions as well. I mean, this connectivity challenges with things. I mean, if you think about a scenario where you've got the service bus only able to process, say, 2,000 messages a second, and you want to go way beyond that. You want to broadcast messages to millions of devices, or you've got maybe a mobile phone application, and you want to broadcast to hundreds of thousands of people or millions of people. And the Event Hub is really building on the Service Bus technology to actually increase the capacity and provide availability to mobile devices. So, for example, it does provide integration with the messaging services that we've got for the iPhone, for the Android applications, and also for the Windows applications. So you can send these device notifications. And also, they're working on technologies with the Internet of Things to be able to handle these scenarios, like I think it was Coca-Cola. They just bought, several million network IDs because all the Coca-Cola dispensers in, stores like McDonald's and Burger King are going to have, this option to, send telemetry data. So they need to be able to have, massive capacity for these Internet of Things applications. So the technology is definitely emerging there to be able to allow these capabilities.
om man kan säga att eventhubben gör det lättare att få väldigt många enheter att kommunicera med Azure och göra det som du gör egentligen med din bilexempel så att säga.
Yeah, so I think we've 3 minutes left if anybody wants any more questions on this.
Är du klar annars, Allan, så kan vi, eller har du någon sista slide du vill visa?
No, I was actually going to finish with a demo of the racing game, but
okay.
Unfortunately I can't do that.
Jag skulle bara vilja ställa frågan, har du varit med om någonting när folk har använt servicebussen på ett felaktigt sätt? Finns det något vanligt sätt att man använder den på ett konstigt sätt?
The only thing I can recall is that we do have like a connection limit in the service bus. So I can't remember offhand if it was 100 or if it was more than that, but kind of like having 100 applications connected to forming an actual connection on the service bus. So because the actual storage queues use the HTTP protocol, they're kind of unlimited. You don't have the concept of forming an actual connection. So if you wanted to have many thousands of applications sending messages, it may be better to consider using the storage queues because you may hit a limit on the service bus queues. I have been aware that has hit some people, but I've not really seen anybody sort of misusing the service bus.
Okay. Allan, skulle du kunna gå till min hemsida basfrog.se så att jag kan presentera vad som kommer framåt i tiden?
Absolutely, yeah.
Som avslutning. Medan Allan gör det så vill jag tacka Allan jättemycket. Jag vet att han väldigt, väldigt gärna hade velat visa sin bilapplikation. Han har skruvat på den länge och det är jättespännande. Och det finns ibland också att Allan har lite prestationer om det. Allan, kommer du ha någonting på Tech Days om din bilspel och så?
Yeah. I mean, I'm going to be doing a session on the Internet of Things and device connectivity. So I'll be talking about the racing game there and car telemetry. I think I'll also be doing a shorter session in a workshop, which will be more sort of level 100 stuff on the Internet of Things. I'll also be hanging around on the Active Solutions stand and on the Microsoft stand as well. And we might actually set up the car racing game on the Active Solution stand if people do want to actually run it. And it's I'll try and get around the user groups as well. I have done it at the .NET user group, and I'm going to submit that session for the SweetHub conference, which is coming up as well. So yeah, I will be going around the conferences and do that.
Så kan du gå till basfrog.se. Då ska vi se vart vi har själva huvudsidan för den här serien. Så det här är min blogg. Jag hoppas att det går lite snabbt att få fram den. Och här kommer det komma upp en liten tile som vi är så förtjusta i, som det står Azure Online Seminarium. Så kan du klicka på den, alla.
I thought I was in the Azure portal then. It looks very similar. This one here.
Ja, nästan. De tittade på min blogg och så tänkte de, men det här var ju bra. Alltså. Så här så ser vi, här är huvudsidan för den här sektionen och här lägger vi upp länkar och sånt. Så Allan och jag kommer att skicka ut ett mejl och också lägga upp länkar här så att ni får lite mer information om till exempel en hybrid connection som jag pratade om, eventhubben och sådär. Så det vi också ser att nästa vecka kommer att vara spännande den 23 oktober. Då kommer Peter Brynsson att prata om Azure Mobile Services, vilket är en jätteintressant tjänst för att egentligen skapa API och konsumera API på väldigt många plattformar. Allt från JavaScript till .NET till iOS och Android. Och här finns det också en speciell implementation av servicebussen för att skicka notifieringar till alla dessa mobila plattformar. Och det är också ett ställe som vi liksom använder servicebussen på för att faktiskt skala väldigt bra ut till alla mobila plattformar. Så tack så hemskt mycket, Allan. Vi kommer att lägga upp inspelningen här och vi kommer också att skicka ut länkar till er via mail. Tack så mycket, och tack så mycket, Allan, för din presentation.
Can I just mention before we sign off about the SWAG meeting that we've got, Sweden Azure User Group meeting?
Ja, visst, sure.
Yeah, so we're going to be having a meeting with the Azure user group next week. It's going to be on the Thursday, and I'll just see if I can bring up the actual homepage. There is a quick link to it, which is swag 23, I think. much.
Det var väldigt långsamt här.
I think I spelled that wrong, so let's just try for that. I spelled bright wrong, so I'll just change that. Yeah, that's it. There is a quick link, which is swag23.eventbrite.com. But this is it's a good opportunity because we've got several developers coming over from Redmond. Dag has been helping to organise this and put this event together. So it's going to be next Thursday at the Active Solution office, and that should be taking a look at the mobile services and the API technologies. Dag, also you've got some contacts of that. Have you mentioned this on your blog or anything like that?
Jag har twittrat om det och såna här saker, så vi har gått ut med det, men desto mer information som vi sprider desto bättre.
Yeah, great. Thanks very much.
Tack så mycket. Hej då.
Thanks for listening.